Good morning. My name is Crystal. This is Catherine, my partner in crime. I flew in, like I said, from San Diego. She is from New York City, but we actually lived together in Atlanta for a while, working at the Weather Channel. So it's good to be back here in the Peach State. We actually did a big weather climate study on peaches last year for a big international farming company. And it may not be the Peach State in the future, based on what we're seeing with crop loss related to the weather. So just an interesting fact there that really has nothing to do with building and construction, which is what we're here to talk about. Our Building Smarter slides here, the impact of our changing weather and climate on construction. So we are not the material and construction experts, but we work with contractors and we definitely know weather. So we're gonna dive into that today and explore some of the changes we're seeing with recent trends in our climate, especially in the last 2 months. We've got some case studies to share and what we've seen in 2024 so far, how weather forecasts shape construction timelines and design decisions, how accurate hyperlocal data improves communication, safety, and planning, understanding how weather affects material performance and durability. We'll discover key forecasting tools for better project management and examine weather's long-term impact on structural resilience. So Catherine and I are partners with Monarch. We started this company about 7 years ago now. We met at the Weather Channel, like I said. That was 11 years ago.
Yes.
When I left the Weather Channel. She was my producer, so she's the one behind the scenes, behind Mike Seidel and Jim Cantori, Stephanie Abrams, making us look and sound great on the air. But I had done the broadcasting for 17 years. I started my career in Idaho Falls, because you got to start somewhere. I had to get out of San Diego to be well-versed in the weather. And I from there went to Denver, Colorado, spent a lot of time studying weather and mountain impacts in Colorado. And from there went to Atlanta to work at the Weather Channel, and then back to Los Angeles at NBC. My family's all in Southern California, so it was important to get back home. And I'm currently in San Diego and operating Monarch from there. And Catherine, I'll let you give a little history about your background.
Yeah, no, thank you. And it's good to see everyone this morning. So I went to, do I sound okay?
Is her mic on?
Okay, great. Or I can just talk louder. We know how to do that. But I went to school at Virginia Tech for undergraduate and graduate school. Why I say that, if there's any Georgia Tech people in here, we'll just be frenemies for today because we play each other almost every single year. But in graduate school, I focused on the impact of how mountain environments impact tornadoes and how they form, how strong they can get, just influenced by the complex terrain of mountains, including here. We're at the base of the Southern Appalachians here in Atlanta. So through my graduate research, I did a lot of computer modeling, a lot of geospatial technology. And so that skill set is what we bring to Monarch in terms of doing custom modeling of weather and climate scenarios, what that means for the construction industry. For example, I found my way into broadcast television, brought those skill sets with me. That's where I met Crystal, as she mentioned. And now we've been off to the races with learning a lot about meteorology in a framework from other types of people like you all here today. Our background is all weather, it's all climate. We know that. But it's the applications to what you all do day in and day out that we're constantly learning and applying in our modeling scenarios.
So we've continued to grow a team of some former broadcast meteorologists who are also sick and tired of waking up at 2 a.m, dark and early for broadcasting. We have GIS experts on our team who help build our products and custom alert system, which we'll go into shortly. But let's dive into some weather first. Catherine, I'll let you start here.
Yes, absolutely. So everyone in here, I'm sure you've either experienced an extreme weather event in the past several years, or you have loved ones that have experienced an extreme weather event that maybe caused damage or injury. And we're seeing an increase in that in just the past 30 years or so, and especially honestly in the past 10 years. We'll talk about some of the more recent damaging events. Climate-related disasters have jumped 83% in the past 20 years, and this is a statistic that continues to change, and that number will continue to go up. Extreme weather disrupts the operating and financial performance of 70% of businesses worldwide. Also expect that number to go up as we get more extreme weather events impacting not just the United States, but globally. And in the next 5 years, climate change will cost companies worldwide $1.3 trillion. And we're not just talking the obvious. A storm comes through and damages a building. It's disrupting supply chain routes. It's disrupting the availability of materials, perhaps the durability and the strength of materials. So it's even all of those different scopes within the obvious damage potential that we're seeing with all of these events.
And we like to explain it from a scientific perspective. You know, we've warmed our Earth about 2 degrees Fahrenheit, which doesn't sound like a lot, but when you're a meteorologist and you're looking at the implications of a warming landscape and especially a warmer ocean, just the 2-degree increase has caused significant impacts. We like to say our changing climate, because in some cases, it's getting colder and we're getting more snowfall, right? So it's not just about global warming. We don't often use that language. We talk about the extremes we're seeing in our weather events, the frequency and intensity of the weather events due to this slight increase in temperature. It's creating a more dynamic jet stream. We're getting more enhanced rainfall. So if there's more evaporation in the atmosphere because of the warming oceans, we're going to see higher rainfall events and even higher snow events in some cases. And then, of course, we'll dive into hurricanes and tornadoes and drought and wildfire and all of those effects as well.
Yes, those are the big headliner events, as we like to say, the ones that capture everyone's attention, do the most damage, and have the biggest footprint. So just last week, NOAA, they updated their list for the 2024 billion-dollar disasters, and we've now had 24. For reference, last year we had 28, and basically just in the last 5 years, we've had more than 20 every single year. Hurricane Ian is an example, Hurricane Ida, another one. We've even had some ice storms that rose to the level of costing $1 billion in damage. This year alone, and with this update, you can see the ones that stand out, the 4 hurricane symbols. So 4 out of the 5 landfalls that we've had this year, which, by the way, if 5 landfalls sound like a lot in a season, it is. It's the second most we've ever seen on record. There's only been 2 other years that have seen 6 hurricane landfalls. But 4 of those, the 2 most recent that I know everyone here is aware of, Hurricane Helene and Hurricane Milton, both made landfall as major hurricanes, so Category 3 or higher, on Florida, and they made landfall within 13 days of each other. That is a record short amount of time to have 2 major hurricanes making landfall in such quick succession. And the timing between these billion-dollar disasters, we're also seeing that frequency increase. So we call it days between disasters. Now we're averaging only about 9 days in between. In the 1980s, we were averaging 80 days in between billion-dollar disasters. So just another example of the strain, which Crystal is going to talk about, that we're seeing on the infrastructure with so frequent disasters.
Thank you, Catherine. Yeah, obviously extreme weather is going to equal higher costs. We'll dive first into infrastructure strain driven by our changing climate. As we say, it's not our grandparents' climate anymore. We have had to adjust climate normals. So even the seasons are shifting, temperature averages are shifting. So it's important for businesses to understand those changes to, be more proactive versus reactive. Just like Catherine mentioned, Hurricane Helene and Milton just together have caused over $300 billion in damages. Another interesting fact about Milton, that was our last storm which made landfall near Tampa. Milton underwent what we call extreme rapid intensification. You've probably heard about the warmer than average waters of the Gulf of Mexico, helping to fuel these hurricanes. So Milton intensified from a Category 1 to a Category 5 in 18 hours, which is unheard of. So less than a day, we go from Cat 1 to Cat 5. That also happened in Acapulco, Mexico. Was that last year?
Yes.
We had a storm go from a tropical storm to a Cat 5 before landfall. So those are the extremes that we're talking about. Floods are on the rise. The federal government issued 2 disaster declarations for floods in 2000. This year, we've had 66 so far. That image, of course, from Hurricane Helene around Asheville. One of our employees lives in that area, and he described it as Katrina in the mountains, just the type of devastation he's dealing with there. And some of the notable flood stats, we're used to 1 in 10 year, 1 in 100 year rainfall events. Around parts of Asheville and Wilmington, we saw totals as high as 25, 30 inches of rainfall, which is unheard of. I come from San Diego, where we're lucky if we get 10 inches in a whole year. So we're getting as much as 30 inches of rain from one event. And those are 1 in 1,000 year rainfall events. So we're just seeing these numbers that are off the charts. That also happened in St. Pete with Hurricane Milton. We had a 5-inch rainfall total in 1 hour. So the infrastructure can't keep up, obviously. And the storm drains were already clogged from the last storm, and it just compounded the problems. Rising costs from natural disasters are first and foremost going to affect recovery and rebuilding efforts. But if you're in this business, you can imagine disruption to supply chains, inflating material prices, labor, and project expenses. Insurance challenges, we know in Florida and California, it's hard to even get insurance in some cases. Premiums are rising, with some insurers actually denying coverage without mitigation strategies. And that's where Monarch comes in. We actually have a company we work with in real estate investment, and they were able to get a lower insurance rate just by committing to working with a weather and climate company like ours.
All right, Catherine.
Yeah, so now we'll get into some applications. You all are probably like, okay, what does this mean for me? So using some case studies and just some real world events that have happened either recently or happening right now. So this summer, it was another record-breaking summer in terms of heat across the Southwest. 2 cities that really stand out, Phoenix and Las Vegas, because of not just the temperatures they experienced. Las Vegas soared to 120 degrees in July, but the duration of heat. I'm sure you all could tell us even more about how maybe one hot day could be an issue in what you do, but 100 hot days. And now we're talking about that duration, that longevity of heat, compounding the issues that might turn into challenges for you all. So Phoenix, 70 days above 115, and a stretch of 113 straight days of 100 plus. For those of us who aren't used to that type of heat, that is unfathomable, that you're stepping outside for 113 days to century level types of temperatures. And then, as I mentioned, Las Vegas, 120 degrees. Las Vegas, every year I read stories about the airport having issues because they have to hold the planes because the runway isn't long enough due to the heat and the hot temperatures. So if anyone has ever been delayed in Phoenix and Las Vegas in the summer, that's probably why. It has nothing to do with thunderstorms. So the risks go beyond those floods, those hurricanes, those tornadoes, again, those headliner events that we talk about. The energy consumption associated with heat, that's an issue. The labor force issues, when you're talking about the desert Southwest being one of those rising regions in terms of development, and a lot of population is flocking there, how do you protect your workforce in heat like that? And a lot of places, Miami stands out in trying to pass local level laws to protect the workers. If it's 95 degrees, then they get water breaks and they get cooling breaks every X hours. A lot of that is getting, stuck in just the talking about it phase and not the executing phase, but we're going to have to really get serious about that. Otherwise, we're going to have delays in construction if people are sick, if they're getting hurt faster because of the heat exhaustion, the heat illness. So our job is to think of that and do those trend models for companies so they can try and figure that out. And that's just from a human perspective. From a physical perspective, heat can obviously have major issues on the durability of whether it be appliances or materials. I know air conditioning units that are in hot climates, they often have a shorter lifespan because the heat just wears these units down in that example.
Great. Speaking of heat, even where I live in San Diego and not too far from the coastline, everyone in my neighborhood has installed air conditioning in the last 10 years because our temperatures have gone up and our overnight lows are going up. We have more moisture in the air, as I've mentioned, so those higher humidity rates make it harder to cool off overnight. And so it was getting too uncomfortable to live without AC. Benefits of accurate weather data for construction sites and timelines. We just feel that it's very important, especially if you live in a severe weather environment, you work in a severe weather environment, to have the enhanced communication and alerts if you don't already have a system in place. The weather, it's not an exact science. Yes, we hear the jokes all the time about how we can be wrong and still have our jobs. The weather is dynamic and it's changing constantly. So it's important to stay up on severe weather alerts, warnings that may come out even 30 minutes prior to a big event if there's a severe thunderstorm in a certain area. This just keeps stakeholders informed. It increases safety and reduces accidents. We work with a contractor in Kansas, so a lot of dynamic weather this year. We didn't even go into severe weather season. We had one of the bigger record-breaking years for tornadoes. So it's really important that the contractor was able to even text or call one of our meteorologists who works, hand in hand with him with any questions he had for safety and just timelines for the project in general. This improves compliance, of course, effective planning, minimizing costs and delays in the long run, allocating resources, durable materials, which we're going to go into in more detail, understanding what the average temperatures are, the snow load in some cases, the wind direction and wind speed that can obviously have a big impact on the orientation of certain buildings and the materials selected. We just did a forensic case out of Atlanta. It was a church that had wind damage to a roof, and so we were able to look back and see how strong those winds were and if that indeed caused the damage on the roof. So understanding which materials are going to be more resilient. Sustainability and orientation, this gets into the energy efficiency and orientation of certain buildings based on sun angle and whatnot. This is something I'm not as familiar with, but Catherine's done a lot of research and we'll do our best to compare material performance and durability to weather trends.
That's right, yes, and this is where you all, I'm sure, will have a lot to say in terms of material durability and comparing the different types with the extreme weather and climate events that we would forecast. So temperature, this one's an easy one, expansion and contraction with extreme heat and also extreme cold. So materials expand in heat, they contract. Potholes are a great example. That's what creates potholes on the road every winter. But that can affect structural integrity. Proper selection accommodates these changes. So that's where metal is better in terms of, wood obviously is very porous. It expands and contracts like crazy when it's hot, cold, or especially in moist environments. So metal can be immune to that type of impact on a structure. Curing. Weather influences the curing of concrete and adhesives, impacting strength. We actually get questions a lot when it comes to a construction site. What is the temperature and humidity going to be? So they're asking if they can pour concrete because that's how important these impacts are to them. And if you can't pour concrete or if it can't dry, obviously we know what happens in that in that case. Moisture and humidity, so water absorption. Wood is mentioned, wood and also concrete, very porous, can weaken from moisture. So moisture resistant materials can help. Metal, again, can help in that case. Even vinyl is another type of material that can be sensitive to moisture and humidity. Freeze-thaw cycles, we're very, very familiar with that. Repeated cycles can cause cracking. Effective drainage enhances that durability. So again, metal is obviously much less likely to crack than wood, for example, when you're talking about moisture. UV exposure, so degradation. Prolonged UV exposure weakens plastics, so UV options extend service life. Metal, again. And another great thing about metal can deflect sunlight, so it can also help with energy concerns or energy costs in that case as well. Wind and erosion, so physical wear, that one's easy. We've all seen, in a hurricane, we can see shingles flapping up on a roof, for example. So high winds can erode materials. And so more robust materials, as well as site orientation, like you were saying, in respect to a prevailing wind direction, that can help reduce wind damage. So a lot of metal roofs, they can withstand winds up to 140 miles per hour. That's the equivalent of an EF3 tornado or a Category 4 hurricane. So that's pretty good when you're talking about worrying about if your roof is going to blow off in one of these extreme weather events. So metal is a great option there. And then chemical reactions, corrosion. So rain, humidity, water, especially in the changing climate, is going to be the big ticket item. Too much or too little. That's what we're going to be dealing with in terms of extremes. And it just impacts everything, including durability of materials. So the corrosion caused by rain and humidity, not as bad when you're using metal over those other types of materials.
Thank you, Catherine. Essential forecasting tools. This is going to be one of our last slides to wrap things up, and then we'd love to hear from you guys if you have any questions. Climate risk assessments. This is something we're doing a lot of lately, looking at physical climate risks for certain site locations, and that obviously helps with long-term planning, meeting codes and environmental standards related to addressing the climate and what we're seeing with new climate normals. We provide seasonal outlooks and data insights for our clients. Again, we can look at historical data for a particular site and predictive data. We can go out 10, 20, 30 years with at least what the trends are going to be. It's obviously a challenge to forecast this far out, but we can look at climate trends, and there are some really impressive climate models out there that are validating and verifying every year. So it's really important to have that in your back pocket. And understanding hyperlocal weekly and daily weather forecasting. I mentioned that before for our client that's in Kansas. What we do is we provide a weekly outlook. So whether it's construction or real estate, we work with a restoration company, we work in agriculture, insurance. We like to give our clients the weekly outlook first for their site-specific location for planning and timing, and then we provide daily briefings as the weather changes, and we set up customized alerts based on all these different weather parameters that can affect a certain location. We actually have a member on our team who worked at the National Weather Service in Norman, Oklahoma, and she was responsible for putting out severe thunderstorm alerts, and we've designed a proprietary hail model, and that's what you're seeing in the image here. So if you're going to have hail golf ball size within 30 minutes at your location, it's really important to be getting those alerts and to have this type of hyper-local hail forecasting. On-demand severe weather support, we were slammed this hurricane season providing on-demand severe support. So our clients often have us join their planning calls, their operations teams, so we can make sure they're well briefed on the weather, the impending weather, and what the exact impacts are going to be. A lot of times, it's going to rain a few inches in a certain area, but does that mean it's going to flood? You have to take into account soil moisture, terrain, population density. There are a lot of factors that go into our weather modeling and advisory services. This is a member of our team, Maria La Rosa, also from the Weather Channel, keeping our clients up to date during Hurricane Milton, actually. So we do a lot of Microsoft Teams chats, depending on what our clients are looking for. We're providing them services based on their needs. And with that, I think we'll wrap it up and see if you have any questions. I know they'd like us to have everybody scan this QR code and participate in the session survey. There's also a yellow form if you prefer the old-fashioned way to fill out the survey. And then we'll go back to that slide after. Thank you for joining us. I hope you learned something insightful.